Okay, so now we are on number 4. Number 4 has, it looks like just a nasty problem because it's to the 5th power. So what we're going to do is we're going to come down here to the 5th row. I'm going to go ahead and highlight the 5th row. See that 5 right there? That's sort of how I use a shortcut to find out where the 5th row is. So there it is right there. So 1, 5, 10, 10, 5, 1. 1, 5, 10, 10, 5, 1. And that's where I'm going to start. 1, 5, 10, 10, 5, 1. I almost need a bigger piece of, wider piece of paper for this. So, you take the 7, and what you're going to do is you're just going to do the same kind of deal as you did in the last question. But you take the 7, since it's the first term, and you say 7 to the 5th, 7 to the 4th, 7 to the 3rd, 7 squared, times 7 to the 1st, times 7 to the 0. Now, do I really have to write anything to the 0 power? No, I don't. Just wanted to at least show it to you. Okay, and now I have the y. Remember, the y needs to go in the opposite direction. So I like to start on the far right, say y to the 5th, y to the 4th, y to the 3rd, y to the 2nd, y to the 1st, y to the 0. Now 7 to the 5th power is a big number, so 7, I don't have that one memorized. 7 to the 5th, 16,807. Okay? 16,807. In other words, 16,807 plus 7 to the 4th times 5. Please have your calculator handy. And actually practice doing this with me. Because if you don't type it in your calculator and you wait for a quiz or test, chances are you're gonna do some of the operations incorrectly, and you're not going to remember how to do some other ones. So here it is. It's 12,005 y plus, remember to cube the 7 before you multiply by 10. Now don't say 21, okay? 7 cubes different. 7 to the 3rd, 7 times 7 times 7 is 343 times 10, 3430 y squared plus 7 squared is 49, so 490 y to the 3rd plus 5 times 7 to the 1st. 7 to the 1st is just 7, so 7 times 5 35, y to the 4th, and then this is a 1, this is a 1, and that's y to the 5th. And in previous exercises in this book, I noticed that it asked questions for you to rearrange the variables from highest degree to lowest degree. So that's how I'm going to rearrange this answer. Y to the 5th plus 35, y to the 4th plus 490 y to the 3rd plus 3430 y squared plus 12,005 y plus 16,807. And that is your binomial expansion. Whew. These problems do get very lengthy, and if you ever get lost, just rewind it, pause it, watch it again, and hopefully it'll help you out. Alright, next question. Next question is even a higher power. It's to the 6th power. So what I want you to do there is look at Pascal's triangle. Now Pascal's triangle continues on, okay? However many rows you want to write. But this one here is the one that we're going to be using because it's the 6th row. Actually, I noticed that I wrote the wrong entry there. 15, 20, 15, and then this is a 6. So 1, 6, 15, 20, 15, 6, 1. 1, 6, 15, 20, 15, 6, 1. So those are your first few. Those are your coefficients. 1, 6, 15, 20, 15, 6, 1. Now I organized this on 2 lines just because my paper's not wide enough to hold the rest of this question. So here's what we're going to do. You see the power, the 6th power. So we used those coefficients. That's the whole reason we use those coefficients. But remember now we take the first variable, or the first entry, whatever it is, the term, and use x to the 6th, 5th, 4th, 3rd, and so forth. X to the 6th, 5th, 4th, 3rd, squared, and to the 1st. And remember I mentioned in the last question that I don't really have to write anything to the 0 power, so I'm not going to write it here. Okay? And then now I want you to pay close attention to what we're doing here. We're going to take this -1, we're going to raise it to the 6th power way out here. And notice that I used a parentheses. The parentheses are of utmost importance. In the last questions, I did not have to use parentheses. And the reason is that everything that I was raising to a power was positive. Number 7 has a negative. Okay? So that negative has to be in parentheses when you raise it to a power. So here we go. -1 to the 5th. -1 to the 4th. -1 to the 3rd. -1 squared. -1 to the 1st. And again, I don't have to write -1 to the 0 because we all know that is +1. Okay? So now let's try to go ahead and write the final answer. I think we can do this. X to the 6th. Now, is this one going to give us a positive answer or a negative? It's actually a negative because -1 to the 1 is negative. So -1 times 6, -6x to the 5th. This one's going to be positive. See, that cancels out. It's positive 15x to the 4th. Negative to the 3rd gives you a negative, so -20x to the 3rd. -1 to the 4th gives you a positive, so positive 15x squared. -1 to the 5th, -6x. And -1 to the 6th gives you +1. And that is actually your final answer. But I want you to realize that whenever you have subtraction in a binomial, look what happens to the signs. You have alternating signs. It goes plus, minus, plus, minus, plus, minus, plus. Okay, so they alternate signs with the first one always being positive. So if you can remember to alternate signs, then you don't have to use parentheses and plug a negative number in the powers, or I'm sorry, in your when you're solving the question. So